Hello everyone, welcome to Mindspan Education. So in this video we are going to solve or we are going to practice problems based on the probability and statistics, right? And we are going to pick the question from GATE DA 2025 question paper, right? And we are going to go through each and every question of that, and we will have the complete explanation of each and every question, right? And one info that I wanted to give you, that how you can access the previous year questions of GATE DA, right? So what we have done, we have made this previous year questions as a test series, and that will be completely free to enroll. You will not have to worry about that. So you see there are two cards, and one card is for the GATE DA 2026 test series, and the another card is GATE DA free PYQ, right? So this is the section where you can access the previous year questions of the GATE DA. So we have already this GATE DA 26 test series that is going on, and it is on the discount of 25%. So this will be valid till 31st of July. So you will get this test series at 999. So, and you can go and check out all the details and the announcement if you would like to enroll. Okay, let's look at this section where we have this GATE free PYQ test series. So you can just click on the view details, and here on the available test, so you will have to first enroll, and enrollment is free. You will be not paying anything for that. You see we have here GATE DA 2024 and 2025. Click on start test. You will be able to attempt like a test series. Start test, click on the declaration, and I am ready to begin, right? So you can see, so we are going to go through all the probabilities question, right? So let me see first of all how many probabilities questions are there in this paper. So I think I should pick one by one, and I should start solving them. That would be good idea, right? So let's start picking this first question that is based on the iterative expectation, and yeah, let's pick one by one and try to solve all those questions. And one more info I would like to share with you, that we have completed the phase 1. Phase 1, if you have already gone through our announcement, phase 1 what we have, so phase 1 is covering all the maths of the GATE DA, like linear algebra, probability and statistics, calculus and optimization. So all these lectures are completely free of cost, and we have covered it comprehensively, right? If you go through the lecture, then you will get to know, right? And even so, I will not have to say anything, just go through the lecture, and it is completely free of cost. Go through in your free time when you are not busy or you are doing something else. Just go and watch any random lecture, then you will get to know what we are trying to deliver, right? So everything is completely free, and we have already finished that phase 1. That means linear algebra is completed, probability and statistics is completed, and calculus and optimization is completed, right? And apart from that, if you would like to have a more practice problem, we have so for that you will have to enroll, and the cost of the enrollment is minimal. It is nothing, right? So like if you enroll for the linear algebra, then you will get the 250 plus questions, right? And all the question pattern will be followed as per the GATE question pattern, right? So you can just go and look out all those questions. So there are 250 plus questions, and each question will have the explanation step by step. Each question, शायद ही कोई क्वेश्चन होगा जिसका कि एक्सप्लेनेशन हमने नहीं दिया होगा. Each and every question has the explanation, right? Similarly for the probability and statistics, you will find right now I have attached 200 plus question, and I am adding more question. And similarly Rajiv sir also had is adding questions into the calculus and optimization. So for the calculus and optimization you will find at least 150 plus question, right? And the thing is that you can just enroll it with the minimal cost, right? Once you will enroll it, then you will get to know that what kind of questions are there, right? And all those questions are chapter wise. So it is just for you as a building blocks so that you can build up your concept, go through the lectures, solve the problems. And these are nothing, these 200 and 400 questions are nothing. The more questions you will solve, it is better, right? So all these questions that we have put in are quality questions. They will help you to build up your concept, right? Okay, I think I have talked a lot. Usually I don't do that, but I think I should do that, right? So yeah, let's start with our this lecture. And if you would like to have any details about our test series or about our course, you can just mail us, you can just message on the telegram, whatever, how would you like to connect, you can connect with us. Alright, and if you want to have the details, you can just go to the mindisfaneducation.com. You will have each and every details, right? Okay, now let's start with this very first question of GATE DA 2025. Okay, let's start with the very first question. Suppose x and y are random variables. The conditional expectation of x given y is denoted by this. Then we need to find what will be the expectation of this conditional expectation. We have already covered. So this is what we call the iterative law of expectation, and we have already seen that the iterative law of expectation is nothing but the total expectation theorem, right? So let's try to look at this problem. So this is not a problem, this is a result of the iterative law. So if you have already gone through, then you can directly tick what will be the answer to this question. But anyhow, let me go through one more time so that you have the idea. And if you do not have, or if you have not yet explored this type of concept, I would request to go through my playlist. You will have a detailed analysis of all this. So you see what is this. So this is a conditional expectation. So this conditional expectation, we can think of a random variable, right? So if you look at this, the expectation of this random variable x given y. So depending upon what the value this random variable y will take, so let me go through one more time. So maybe y will take the value that is y is equals to little 1 y1, right? So for that we will have some numerical value, right? Or maybe the y will take some another value, and based on whatever the condition we are imposing, then we will have another value, right? So this big capital is a random variable y, and depending upon whatever the y will take, we will have the conditional expectation. That will be some numerical quantity. So overall what I am saying, that these things, that the conditional expectation will be a function of this random variable y, right? So if y takes the value little y, we will have output of this function, or if y takes the value y2, we will have another. So depending upon this y, so overall what I am saying, that this conditional expectation is a random variable which is a function of, or we can directly say, so this is a random variable. So this quantity is a random variable. So what we need to find, we need to find what will be the expectation of this random variable. How we can proceed? We can make use of the So we can simplify it. We know that how to find the expectation of a function. So that would be equal to summation gy times the corresponding probabilities PMF. So PMF of this random variable y, right, and this summation will go over the value of y, right. And what is gy? So gy is nothing but the expectation of x given y times this PMF of this random variable y. Now you recall what is this. So we have this expectation times here some PMF, right. And if you look at this expectation, so in the expectation we have this condition. Think about the total expectation theorem. So we are running over this y. So for all y we are finding this conditional expectation of x given y. So y you can think as a scenario, right. So we are finding this expectation of this random variable y given this scenario, and we are multiplying this expectation with the probability of the scenario. And if you recall from my lecture, this is nothing but the total expectation theorem. And total expectation of what? Total expectation of this random variable x, right. So that would be equal to the expectation of this random variable x. So you just need to here see what is this quantity. So this is nothing but the total expectation theorem, right. And if you able to recognize this, what is this total so if you able to recognize this as a total expectation theorem, then you have the answer, right. So the correct answer for this is C, right. So the main point is that the concept involved with this problem is the iterative expectation or total expectation theorem that you need to go through if you haven't already gone through. And we have covered all these things in a very detailed manner. Okay, now let's jump to the next question. Okay, let's look at this question number 2. Let x be a continuous random variable whose cumulative distribution function for some t is given as follows. If the median of x is 3, what is the value of t? So this is the cumulative distribution function that we have given, and we have given that the median of this random variable x is 3, then what is the value of t? So the very first info that you should have, the median is the value that splits the probability in half. So at least 50% of the probability lie to the left, so and at least 50% of the probability lies to the right of the median, right. So if we try to find the cumulative probabilities, that means the CDF, that means CDF at this median, then we will have half of the probabilities, that means half, right. So now we can just look that. So now here the CDF is 0 when x is less than t. So when x is less than t, so let's suppose this is t, the CDF is 0. That means we haven't accumulated any of the probabilities, right. So obviously median cannot be within this range. Why? Because at least we should have this half of the probabilities. So as per the whatever the CDF we have given, it is saying that we haven't cumulated any probabilities till this point t. So this is the x that this random variable taking the value, right. And from this 4 t to 4, from this t to 4 we have this relation, right. So it would be, I think, a straight line, yes, passing through t. So this is now so we are from t we are started accumulating some probabilities, right? And after x greater than 4 we have accumulated all the probabilities. So this is 1 and this will be 1 divided by 4 minus t times x minus t, right? So here after this point, after so at if we try to find the CDF at 4 we will get 1, right? So that means till here we have accumulated all the probabilities, but what we need half the probability. So obviously median will be lying between some t to 4, right? From t to 4, yes, right? So that means at median, so if we try to find, so that means so at median, that means at the CDF value at median, that would be half, right? And just now we have saw that median is going to fall within this range, right? So 3 will be within this range, so we will have this equation, that is x minus t divided by 4 minus t, and that will be half. And from here we can find that would be 2x. So we can directly put the value of x. Why we are so x is 3 minus t divided by 4 minus t is equals to half. 6 minus 2t is equals to 4 minus t. So from here that would be t is equals to 6 minus 4 is 2, right? So t is equals to 2 is the correct answer for this question. Now let's look at this question number 3. Let x is equals to az plus b, where z is a standard normal random variable. So z is a standard normal random variable. That means z will have a distribution, normal distribution. Since it is a standard normal distribution, so it will have the mean 0 and the variance 1. So this is the one of the information. And a and b are unknown, and this x is a random variable, that is a linear function of this z, right? And here a and b are unknown to us, and we have given some more info, that the expectation of this random variable x is 1, and we have this info that the expectation of this quantity is 2, and we have this info as well. And if you look carefully what it is, so it is x minus expectation of this random variable x ka whole square ka expectation. So here what we are trying to find, we are trying to find the distance of this random variable x from its mean ka whole square ka expectation, and this is nothing but the definition of the variance of this random variable x, and that is given as 4. Alright, so we have, I think, more than enough information in order to find this value a and b. So let me write down. We know the expectation of this random variable x given in the question, that is 1, and the variance of this random variable x given in the question is 4. The expectation of this random variable z, that is, since it is standard normal random variable, so it has the expectation 0, and the variance of this random variable z is 1, right? And apart from this we have one more information, that the expectation of x minus expectation of x times z is equals to minus 2. I think we have more than enough information to just to get the value of a and b. So if we try to find, so we have the relation, the linear relation between random variable x and z related like this. So just take the expectation. So using the linearity on the right hand side, we can write this as expectation a times the expectation of this random variable z plus the expectation of constant will be same as constant, so it will be b. We know the expectation of this random variable x is 1 is equals to a times the expectation of this random variable z is 0 plus b. So from here we can say that b will be 1. Right? Now let's try to find what will be a. So if we look at here in this relation, so that will, if we try to multiply, that will be x times z minus expectation of x times z ka expectation. So if we use the linearity here, then it would be expectation of x z minus expectation. So here we have given the expectation of x is 1, so that will be nothing but the expectation of just simply z, and expectation of z is 0, so this quantity will be overall 0, and that is given as minus 2, so minus 2. And now we have here the expectation of x times z. Okay, so we have also given the relation, right? So we can proceed like this. We have also given the relation between x and z, right? So we can write something like this. So x is equals to a z minus a z plus b, and minus expectation of x is 1 times z, so expectation of this, that is equals to minus 2, right? Now we can have everything in terms of the z, and we have all the info that we need to have regarding this random variable z. So that will be a times z square plus b minus 1 and expectation of z, that is equals to minus 2, and we have already found that the b is equals to 1, so this quantity will be 0, right? And this will be a times the expectation of z square. And what is the value of expectation of z square? So if you look at the expectation, the z is normally distributed, right, with standard normal random variable with 0 mean and 1 variance. So what will be the expectation of z square? So this is nothing. So what will be the variance of this random variable z? So as per the definition of variance of this random variable z is equals to expectation of z minus how far from the mean. So expectation of z का whole square फिर उसका expectation. So this is the definition of the variance of z, right? So this is 0, right? So here the variance of z is nothing but the expectation of z square, and that is we have given that is 1, right? So here this quantity will be 1, so we have found that a is equals to minus 2, right? And we can even verify how. So a is minus 2, so we have got x is equals to minus 2 z plus b is 1, right? So and we have given the variance of this random variable is 4, right? So if we try to find the variance of this random variable x, that we know from the property that variance of a x plus b is nothing but the a square times the variance of this random variable x. So that will be minus 2 ka whole square, that will be 4 times the variance of this random variable z, and there will be no effect of this plus 1, and we know the variance of this random variable z is 1, so 4 times 1 is 4, right? So the variance of this random variable x is 4, right? and we have also given in the question that the variance of this random variable x is equal to 4. Alright, we have solved this question. Now let's proceed for next question. Now let's look at this question number 4. So it is given that the probability that this random variable x takes the value greater than 0 is 1/4 or 0.25 for an exponentially distributed random variable x with the expectation 1 divided by lambda, where expectation denotes what is the value of lambda. So for this question, first of all, you need to have the PDF expression of this exponential random variable. So just go through all the special type of random variable like uniform random variable, exponential random variable, geometrical random variable, Poisson distribution, and binomial, Bernoulli, and the normal distribution, chi-square distribution, t distribution. Go through all the distribution, whatever the distribution mentioned in your syllabus, and keep in your mind the PDF expression of each distribution. Apart from this chi-square and t distribution, you can keep the, or you can just remember all the expression for the probability density function of each distribution and their expectation and their variances, right? So that would be easy and would be good, and it will help you a lot, because a lot of question like this question, if you know the PDF of this random variable, PDF of this exponential random variable, then you are good to go with this question, right? So what will be the PDF of the exponential random variable? So the PDF of this exponential random variable is only for the positive side, right? It takes only the probabilities are distributed only for values of x greater than 0. So it will have 0 probabilities when x is less than 0, and it will have the probabilities distributed according to this function lambda e to the power minus lambda x, right? And we have given the probability that random variable x takes the value greater than 2 is 1/4, right? So we just need to find this thing, that integration from 2 to infinity and lambda e to the power minus lambda x is equals to 1/4, right? So lambda, what will be the integration of e to the power minus lambda x? So we will have in the denominator minus lambda, and the integration of that will be itself 2 to infinity 1 divided by 4. Here if you put minus infinity, 0 minus e to the power minus 2x, so overall it will turn out e to the power minus 2 lambda is equals to 1 divided by 4. Take the log both side. So on the left hand side it will be minus 2 lambda, and on the right hand side it will be ln 1 divided by 4, and which can be written as, so if you try to find the lambda from here, you will not get any answer, so you will have to do the further simplification of this ln. So this can be written at minus ln 4, right? So this, and further we can write like this. So this 4 can be written as 2 to the power 2. So overall this can be written as minus 2 ln 2, and here we have minus 2 lambda, so this will get cancelled. So lambda is equals to ln 2. This matches your answer, so A is the correct answer for this. Alright, now let's look at this question number 5. So all these are questions from GATE DA 2025 paper. So the question is, there are 3 boxes containing white ball and black balls. So we have the 3 boxes, 1, 2 and 3. Box 1 contains 2 black and 1 white. Box 2 contains 1 black and 2 white, box 3 contains 3 black and 3 white. In a random experiment, one of the boxes is selected where the probability of choosing box 1 is half and probability of choosing the box 2 is 1/6 and for 3 is 1/3. A ball is drawn at random from the selected box. Given that the ball drawn is white, the probability that the drawn from box 2 is. So this is a very easy question based on the conditional probability. So we just need to find the probability that the given we have this info that white ball has been drawn, so white ball has been drawn, and given this information we have to find the probability that it has been drawn from box 2, right? So what we need to do, first of all we need to find the total probability or the probability of this conditional event. So what will be the probability of choosing the white ball? So we need to just find the total probability of choosing the white ball. So white ball can be chosen from this first box. So maybe the first box have been selected with the probability half, and if this has been selected, then the getting the ball white have the probability 1 divided by 3, plus maybe we have selected box 2 and getting the white ball from the box 2 have the probability 2 divided by 3, or maybe we have selected box 3 with the probability 1 divided by 3 and selecting the white ball from the box 3 have the probability 3 divided by 6. And what is the favorable? So given this information we need to look at what is favoring. So we need to find that the probability of box 2, so given this box 2 has been selected, what's the probability of selecting the white ball? So this event that will favor, right? So what will be this probability? So choosing the box 1, box 2 have the probability 1/6 times what will be this probability that the we have selected the box 2 and given this information what the probability of the choosing the white ball. So it will have the probability that is 1 divided by 6, sorry 1 divided by 2 divided by 3, right? So this is event that will favor, so that is 2 divided by 18 and divided by this total probability of selecting the white ball. So that will be, let me do one thing. So we just need so here 18, this is 18, so we can make this one 18. So 3 times 2, let's make 18 by multiplying 3. So now we will have here 18. So overall this will be 3 plus 2, 5 plus 3, 8 divided by 18. So this will be 8 divided by 18. So this 8 will get cancelled. So you will have 2 divided by 4, that is 1 divided by 2, sorry 1 divided by 4. So that is 0.25. So the answer to this question is 0.25. Right. So this was the easy question based on the conditional probability, or if you would like to say based on the Bayes theorem. Alright, let's look at next problem. Okay, now let's look at this question number 6. Y is equals to z square, where z is related to x like this, where x is a normal random variable with a mean mu and variance sigma square. The variance of y is. So this random variable x is a normal random variable, so it is normal random variable with mean mu and variance sigma square. All right, and we have given that this z is equals to x minus mu divided by sigma. Okay, and then we have to find what will be the variance of this random variable y, and y have given y is equals to z square. Okay, so what will be the variance of this random variable y? Again, if you know the distributions, the standard distribution, then the special kind of distribution that you should suppose to know, then this question you can solve within 10 seconds. All right, so if you see what is this, we have done a lot of time this thing. So this random variable z is a standard normal random variable with the mean 0 and it will have the variance 1, right? So what we are doing, how so this is a random variable that has the mean mu and the variance sigma square, right? And this z is a standardized version of this random variable z, so random variable x. So we are trying to shift this x, the mean of this random variable x, to 0, and the variance we are trying to make 1. So this is how we standardized, and we have done this multiple times, right? And we have this given that random variable y is equals to the z square. What is this z? So this z is nothing but the normal distribution, standard normal distribution with mean 0 and the variance 1, right? Now recall the chi-square distribution. So if the chi-square distribution, so what you do is, let's suppose you have these random variables z1, z2, z3 and zn, and all these random variables are standard normal random variable with mean 0 and the variance 1, right? And you take the square of these random variables, x1 chi-square and x2 chi-square and x3 chi-square dot 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 x n chi-square, right? And add all these. What you will get, let's suppose something y. So this y is nothing but it is a chi-square distribution with degree of freedom n. So how many terms you have added here, that will say about the degree of freedom. So here in this case the degree of freedom is 1. So here in our case this random variable y is a chi-square distribution with a degree of freedom 1, and we know the variance of chi-square distribution is 2 times k. So and this k is degree of freedom, so let me write here 2 times the degree of freedom, so 2 and degree of freedom is 1, so the variance of this random variable y will be 2. Okay, now let's solve this question. Consider a cumulative distribution function CDF of a random variable x. So we have given the CDF of random variable x. The value of the probability of happening this event. So if you look at here, we have given the x square. We have been asked the probability that x square takes the value less than equals to 0.25, right? And we have given the distribution of random variable x. So if you look at this event, that the probability that this random variable x square takes the value less than equals to 0.25, it is equivalent to taking the x greater than equals to minus 0.5 से लेकर के 0.5, right? These two events are equivalent and both will have the same probabilities. So now we can work on the given CDF, right? So x takes the value from 0 to minus 0.5 to 0.5, that will fall within this. So we know from the properties of the CDF, happening of this event is equivalent to saying in terms of the cumulative probability, that is the CDF, that will be the CDF values of this random variable x calculated at 0.5 minus the CDF of this random variable x calculated at minus 0.5. Right, so what we are doing here, if you know this property, so there is nothing hidden within this property. So if you know how the CDF works, so what you are doing, so you want to find the probabilities between these two ranges, right, within these two ranges. So as per the definition of CDF, what is this? So this is nothing but the probability that random variable x takes the value less than equals to 0.5. And what is this? This is nothing but the probability that random variable x takes the value less than equals to minus 0.5. Right, we need to find the probability within this interval, right? So what will be this probability? So this probability will be, so all the probability cumulated till 0.5, right? And we are subtracting this part, this thing, right? So probability that random variable x takes the value less than equals to minus 0.5. So we are subtracting this part. So from the blue probabilities we are subtracting the yellow probabilities, so we will have this range, right? So this is I explained this property, so even you should know, because this is a very basic one. Right, now we just need to put the value, so that would be 1 divided by 4, x is 0.5. Let me write it half instead of 0.5. Half plus 1 ka whole square minus 1 by 4, now calculated at minus 0.5, so that will be minus half plus 1 ka whole square. Right, now you can do the further calculation, that will be 1 divided by 4. Here we will have 9 divided by 4 minus half 1 divided by 4, right? So that will be 1 divided by 4 into 8 divided by 4. So overall we will have 1 divided by 2, that is 0.5. So C is the correct answer for this question. Alright, now let's proceed for next question. Okay, so now the question number 8. A random variable x is said to be distributed as per Bernoulli, denoted by this if. So what is Bernoulli random variable? We know that if this x is a Bernoulli random variable, either it can take the value success or it can take the value failure, so either 1 or 0, right? And now we have given that let y is equals to sum of these Bernoulli random variable, and how many sums are there? There are 300 such terms in the sum. So y is a random variable, that is the sum of these Bernoulli random variable, right? And all these Bernoulli random variables, so x1, x2, x3, so all these random variables, so all these xi's are Bernoulli random variable, and they are independent and identically distributed random variable with theta is equals to 0.25. That means, so here this point is important, that they are independent and identically distributed. So all these xi's are IID, and all these are Bernoulli random variable, and they have the probability of success, that is 0.25, or probability of taking the value random variable taking the value x is equals to 1 is 0.25. The value, we need to find the probability that this random variable y takes the value 60, in between 60 to 90. So we have to find the probability of this event after, this one is also important, that after approximation through central limit theorem is given by. So we need to anyhow approximate this probability calculation using the central limit theorem, right? And if you have already gone through the central limit theorem, then just reading question till here, you would have recognized that this question is based on the central limit theorem, right? Okay, so this is one of the easiest question based on the central limit theorem. How we can proceed? We know, so we have this random variable y, and this random variable y is the sum of these random variable x1, x2 dot 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 till x 300. So how many such random variable we have? 300. So n is equals to 300, and we have sufficiently large n so that we can apply the central limit theorem easily, right? We will not have any kind of doubt while applying, and even in the question it has given that we can make use of the approximation of the central limit theorem. Alright, so we need to find the probability of this event, the probability of event that y takes the value greater than 60 and less than 90. Right, how we can do that? First of all, in order to apply the central limit theorem, we will have to make the standardized version of this random variable y, right? And in order to do that, what we need to have the expectation of this random variable y. And what will be the expectation of this random variable y? The expectation of this random variable y is the expectation of this sum, right? And all these are independent, and doesn't matter if it is independent or not, anyhow the linearity of the expectation will hold in any case. So the expectation of these individual random variable, or the expectation of the sum of these random variable, will be equal to the expectation of each one. So we have such 300 terms, right? And for the Bernoulli random variable, we know what is the expectation. So if this, let's say this x1 is a Bernoulli random variable, then what will be the expectation of this Bernoulli random variable? It is nothing but it is equal to the probability of success. The probability of success is 0.25, right? And let me also find what is the variance of this random variable x1. So this random variable x1 is a Bernoulli distributed. The variance, we know that it is success times failure, so that is 0.25 times 0.75. So this is the variance of a Bernoulli random variable. Now we are going to make use of this information to find the expectation of this random variable y, and as well as variance, and after that we will find the standard deviation of this random variable y, right? So what will be the expectation? The expectation of this random variable y will n times the expectation of one random variable. Expectation of one random variable is Bernoulli distributed, and we have such 300 terms, right? So I am using the linearity of the expectation, so 300 times each one's expectation is 0.25, right? So that will be 75. What will be the variance of this random variable y? So recall, what will be the variance of the sum of these random variable? And the very important point is given that all these random variables are independent. So variance of x plus y, if these x and y are independent, there would be no terms of the covariance, right? So we can write, if these two random variables x and y are independent, will be the variance of x plus variance of y. So variance of the individual one. So in this case, all these are random variable are independent, so we can just write as a variance of individual, sum of the variance of individual random variable. So that would be, we have such 300 terms, and the variance of each one, the variance of each one is 0.25 times 0.75, and how much it will be? So anyhow we will have to find the standard deviation. So standard deviation is what? Standard deviation is root over of the variance. So standard deviation is root over of the variance. So we will have here, what will be the root over of this? So 0.25 is here, 0.25 times 3 will be here, and so 10 times, so 10 times 0.25 times 3. You can do the calculation, this is what you will get. So that will be 7.5. So the standard deviation of this random variable y is 7.5. Let me recheck one more time. So that would be 0.75 and okay, that is correct. Now we are going to make the standardized version of this random variable y. In order to do that, what we are going to do, so if you do not know all this concept, I would request you to go through all my lectures. You will have a better idea of all these concepts. We have already gone through in a very detailed manner through all this concept. And we have this 90 here, here 60 we have. Right, so how we are going to make the standardized version of this random variable? So simply subtract the mean from this y. So how much the mean of this random variable y is? 75. So you are going to subtract this mean, and in order to balance this inequality, you are going to subtract from both the side, right, and then divide by the standard deviation of this random variable. So this random variable y, right, so standard deviation we have found, that is 7.5, and in order to balance the inequality, you are going to do on the both side, right. And now here comes the central limit theorem. What central limit theorem says? That this random variable, that is y, or the standardized version of this random variable y, for sufficiently large or greater than 30 or maybe 40, 50, whatever, but we have here 300, so that is sufficiently large. So for sufficiently large n, this or the standardized version of this random variable y will have the CDF that would be of a form of normal distribution, or you can directly say that it will have a shape of, or the distribution that will be standard normal distribution, right. So this will have the distribution that will be approximately a standard normal distribution with the mean 0 and the standard deviation 1, right. So this is what the central limit theorem says. And the benefit of using that, now you can just look at the table, the standard table. Anyhow, we do not need to look for this particular problem because we have already given the options in terms of the CDF notation. So once you have this standard normal random variable, what you can do, you can make use of the table and you can find this kind of probability. A numerical answer you can find, numerical values you can find for this probability. Anyhow, we just need to write in terms of the CDF notation. So now let me proceed further. So this will be 15 divided by 7 minus 15 divided by 7.5, and that would be so now let me write this one, y minus 75 divided by 7.5 less than equals to 15 divided by 7.5. This will be 10. So here okay, so anyhow 75 times 2 will be 150, right. So this 2, and here we will have 2, so that will be equal to minus 2 greater than equals to this random variable, and this random variable will be approximately normal random variable. So we can write using the CDF notation, that will be equal to the CDF calculated at 2 minus CDF calculated at minus 2, right. So this is the answer to your question. So option 1, that was one of the easiest question based on the central limit theorem. Alright, let me proceed with the next. Okay, now let's look at this question number 9. For x belongs to a real number, the floor function is denoted by this and defined as follow. So we have also given that how this floor function has been defined, right, and this is how it has been defined. So we will talk more about that. Let me read out the further question. Where k is an integer and we have this random variable y, and this random variable y is equals to the random variable x, the floor of this random variable x, right? And we have also given this information that the random variable x is exponentially distributed with the mean 1 divided by ln 10, right? So if you recall the PDF of this random variable, the PDF of this random variable is lambda e to the power minus lambda x, and when so the exponential random variable, the probabilities are distributed only for the positive values of x. So when x is greater than 0, greater than or equals to 0, right? So this is the PDF, and we have the expectation of this random variable, and that is equals to 1 divided by lambda, and that is given, that is 1 upon ln 10. So from here what we can say, that this lambda will be ln 10 log natural log 10, right? So for any positive integer l, one can write the probability of this event y taking the value l as follows. Okay, so this one is also easy question. So let me first of all explain you that what are the things that is given to us. So for this random variable x is equals to this random variable x, right? But we have the floor function. So and this random variable x can take the value. So this random variable x is exponentially distributed, and so it can take the value from 0 to infinity. So this x, and how we have defined this floor function, let me go through that. What are the values this random variable y will take, right? So x can take the value from 0 to infinity, and so when this random variable x takes the value from, let's say, 0 to 1, then y will take the value that is equal to 0, right? As per how we have defined the floor function. When random variable x takes the value from 1 to 2, then this random variable y will take the value that is equal to 1, and so on. If random variable x takes the value, let's say, from l to l plus 1, then in that case y will take the value, this random variable y will take the value l, right? And we need to find this probability that random variable y takes the value little l, and this is equivalent to happening of this event, right? And we know everything about this random variable x, right? So if we find the probability of this event, then we will get to know what will the probability of this event, right? And we will have this. So let's try to find the probability of this event, the probability that this random variable x takes the value from l to l plus 1, and that will be equal to happening of this event, that is y takes the value 1, right? So this is exponentially distributed, so we can simply integrate to find this probability. We can simply integrate it from l to l plus 1, and what's the PDF we have? PDF is lambda e to the power minus lambda x dx, right? How do you carry out the integration? So this integration is easy, so that will be e to the power, so lambda will get cancelled, minus 1 will be outside, so it will be e to the power l times minus l lambda minus e to the power minus lambda times l plus 1. So this is what you will get after evaluation of this integral, right? Let me proceed further, and one more thing, we have given this lambda, that is ln 10. So from here you can see we can take the common, what we can take the common e to the power minus lambda l, right? And if we take the common here, we will have 1 minus e to the power minus lambda, right? Now let's put the value of lambda, so that will be equal to e to the power minus, so ln 10, ln 10 is nothing but log base e to the power 10, right? So here you will have to use some properties of the logarithm. So 1 minus e to the power minus log e to the power 10, right? And here we have missed the l, so here it will be l also. So this will be equivalent to so you can make use of the property of the logarithm, so that will be equal to 10 lambda l to the power minus 1, right? And here we will have 1 minus, so that would be equal to 10 to the power minus 1. And what's the property that I am using? Let me recall that one also. So some b to the power log base e to the power a is equivalently equal to a, right? So this is the property that I am using, right? And now from here we can write that would be 0.1 so L will not be here, it will be here, it will be not here, but so this is lambda, right? So L will be here, so here 0.1, so due to this minus 1 it will be 0.1 to the power L times 1 minus and this will be 0.1, right? So you see we have given this same form as in question. So what will be the q value? The value of the q will be 0.1, right? So 0.1 to the power L minus 1 minus q, so here it will be 0.1. So what was interesting in this question, that just they have given this random variable as a floor function of this random variable x, right? And here we have just used some logarithm property. So that was all in this question. There was nothing interesting about this question. So let me proceed with next question. Now next question, question number 10. A random experiment consists of throwing 100 fair die. Each die have 6 faces numbered from 1 to 6. An event A represents the set of all outcomes where at least one of the die shows a 1. Then what will the probability of this event A? So what is this event A? So A represents the set of all outcomes where at least कम से कम एक जो है वो आना ही चाहिए. 1 to 6 अगर आप थ्रो कर रहे हो तो कम से कम एक बार एक आना चाहिए, तो उसका प्रोबेबिलिटी आपको फाइंड करना है, राइट? सो ये बहुत ही ईजी क्वेश्चन है, दिस वन इज़ वेरी इजी क्वेश्चन. सो कैसे आप कर सकते हो? इसका कॉम्प्लीमेंट इवेंट देख लो. कॉम्प्लीमेंट इवेंट क्या होगा? व्हाट विल बी द कॉम्प्लीमेंट इवेंट ऑफ दिस पर्टिकुलर इवेंट? सो द ए कॉम्प्लीमेंट होगा कि एक भी 1 ना आए, सारा जो है वो 2 से लेकर के 6 तक ही आए. उसका प्रोबेबिलिटी क्या होगा? इन 100 फेयर डाई, अगर आप 100 टाइम्स डाई को रोल कर रहे हो और ईच रोल इज़ इंडिपेंडेंट, सो 2 से 6 के बीच आए, पॉसिबल 6 आउटकम है, तो हर एक जो होगा वो मतलब 5 नंबर जो वो फेवरेबल है आउट ऑफ 6. दैट मीन्स एंड यू आर डूइंग ईच एक्सपेरिमेंट इंडिपेंडेंटली. सो probability of this A complement will be 5 divided by 6 to the power 100, right? And what will be the probability of this event A? That will be 1 minus the probability of this A complement, so that will be 1 minus 5 divided by 6 to the power 100. तो ये बहुत मतलब जेनरिक क्वेश्चन है, बहुत बार इस टाइप का पूछा गया. आप अगर प्रीवियस ईयर उठा कर देखोगे तो you will find a lot of question based on this. Alright, now let me move to next question. Now let's look at this question number 11. Consider a coin toss experiment where the probability of head showing up is P. In the ith coin toss, let xi is equals to 1 if head appears and xi is equals to 0 if tail appears. Consider this average. So this is nothing but the average of these, or the sample average, whatever you would like to call. So this is the average of this P, where n is the total number of independent coin toss. Which of the following statement is true? So we just have to look at the expected value of this P hat, and also we have to look at the variance of this P hat, right? So let first of all understand this, what is this P hat. So this P hat is equal to the sum of these random variables from I is equals to 1 to n and divided by the total number of random variables, right? So you can write like this. So x1 plus dot 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 plus xn divided by the total number of samples or total number of random variable that you are adding, right? And we are calling this as a P hat. And if you look at this random variable, each x1 random variable, so because all these x1 random variables are the Bernoulli random variable, either it can take the value 1 or it can take the value 0, right? So what we can say about all these x1, x2 and xn. So if we say about x1, then we are going to say about all, because all these are the Bernoulli one. So expected value of this x1, what will be? In case of the Bernoulli, it is nothing but the probability of success. What the probability of success is P, right? Where the heading showing head. So let's call this that xi takes the value 1 if heads appear. So success is when you are getting the head. So it is P, small p, right? And what will be the variance of this random variable x1? So that is nothing but P times success times failure. So P times 1 minus P, right? So if we know about x1, you know x2, x3, x4, xn, because all these random variables are Bernoulli. Now we have to just look at the expectation of this P and the variance of this P. This one is also a very easy question. So expectation of this P hat is equal to the expectation of this x1 till xn divided by n. So we can simply put out this n outside because this n is constant, and all these random variables are independent, right? x1. So we are looking at the sum of these random variable, and all these are independent. And so irrespective of whatever it is, independent or dependent, we can make use of the linearity of the expectation, right? That property. So expectation of this sum will be how many such random variables are there, and random variables are there, times each one have the expectation P, so times P, right? So this n will get cancelled, so you will get the small p, right? So the expectation of this P hat is small p. Now coming to the variance of this random variable, so we just need to find out also that if n increases, so we will ultimately have to find this variance. Then you will able to figure it out for this question, for this option C and D, right? So let's look at the variance of this random variable P hat, right? So variance of this random variable P hat is equals to variance of this random variable, that is the sum of these random variables divided by n, right? How do we find the variance? It is also easy because we have already given that all these random variables are independent, and we know if random variables are independent, let's suppose these two random variables, we are finding the sum of these two random variable, the variance of sum of these two random variable, and if these two random variables are independent, then there will be no involvement of the covariance or correlation term, so it will just a sum of the variance of these individual random variable, right? So now we can make use of this here. So how many such terms we have? N such terms. So n, and one more property about the variance. So if we have the variance of a times x, then we know it will be a square times variance of x, right? So this is constant, that is 1 divided by n. So it will be 1 divided by n ka whole square times the variance of this sum. How many terms we have? We have n such terms, and variance of each one is that is p times 1 minus p, right? So overall the variance will be p times 1 minus p divided by n, right? Now let's look at this. So this b will be incorrect because this is correct. As n increases, variance of p hat decreases. Obviously, as we increase the n, the variance will decrease. So this is correct. Variance of p hat doesn't depend on n, so this is incorrect. It does depend on n, right? So that was a very easy question, and we have already done these things in the central limit theorem multiple times. We have done these things, I think, in central limit theorem and in hypothesis testing and in even confidence interval. So these are the things that will reflect again and again. So we have covered comprehensively these things, right? So all right, let's look at next question. Okay, let's look at this question number 12. A bag contains 5 white ball and 10 black ball in a random experiment. N balls are drawn from the bag one at a time with replacement. Let Sn denotes the total number of black ball drawn in the experiment. The expected value of this random variable. So we need to find the expectation of this random variable S. And what is this random variable X? This random variable X is the total number of black balls drawn, right? So in a bag we have how many black balls? 5 white balls and 10 black balls, and we are drawing it from this bag and with the replacement, right? So how we can think of this kind of problem? Simplify this problem using some simple random variable. Whenever you have some kind of sum, the random variable is denoting as the sum of something, try to simplify it. So let's take a random variable x, and this random variable will take the value 1 when we have got the black ball, and this random variable will take the value 0 when we have not got the black ball, that means we have got the white ball, right? And how many such trials we are doing? We are doing for S100, that means for n 100 number of trials we are doing, that means 100 times we are picking the ball from this bag, right? So what will be this S100? So S100 is what? S100 is the total number of black balls. So if we have to count the black ball, that means on the first we can represent, so first we will go and draw, we might get the black ball or not. So that means I am representing that thing as this random variable, that x1, right? So basically this random variable x1 is nothing, x is nothing but a Bernoulli random variable, and since we have multiple, so we can just say the xi, right, where I is from 1 to 100, right? Plus again second time I go and try to draw a ball from this, I will get head or not, I will get a black ball or white ball, whatever. So that essence will be captured in this random variable. If I get, then this will be 1. If I get, this will be 0, 1 plus 0, 1 plus 0, something like that. So we will be doing such 100 times. So 1 plus 0, 0 plus 1, or whatever, depending upon whatever we get the black ball or white ball, this random variable will take the corresponding values, right? And we will have at the sum of getting the black balls, that how many black balls we have got in 100 trials, right? And now, so we have break down our this random variable into simple Bernoulli's random variable, right? Now we can find the expectation of this S100, and that is equals to nothing but the expectation of sum of these simple random variables that are nothing but the Bernoulli random variable. And using the linearity, we can write that expectation of x1 plus expectation of x2 dot 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 expectation of x100. And we know everything about Bernoulli random variable, that the expectation of the Bernoulli random variable is p. P is probability of success. So what is the probability of success? Probability of success when we got the black ball. So probability of getting the black ball out of this 15 will be 10 divided by 15, right? So 10 is favorable, total 15. So that would be 2 divided by 3, right? So each one is the same Bernoulli random variable, so each one have the same expectation. So 2 times 3 times how many such Bernoulli? We have 100 such terms, so that would be 200 divided by 3, that is 66.67. So this is your correct answer to this question. Alright, so we have done multiple questions based on that. If you go through our lecture, if you go through our practice problem, then you will find multiple such question that we have already gone through. Okay, I think that was all. So in 2025 paper, GATE DA 2025 paper, we have total of 12 questions from probability. Alright, so we have already covered the complete probability, and whatever the question you have seen, there would be no such concept that I haven't dealt. I think I have dealt more than that, right? So you can just go through and you can have a faith on my lecture, right? And again the key thing is that you will have to do a lot of practice, right? So and so the practice is the key, right? First of all, you should have the clarity of the concept, and once you got the clarity, now comes practice. So you will have to do a lot of practice, right, in order to solve the question in the examination within that 3 hours, right? Once you will do a lot of practice, then you will have a good confidence and you will be able to solve the question, right? The main thing is that the more you solve the question, you will see the patterns, you will see the different type of question. So by looking at different varieties of question, so you what you will be doing, you will be spanning your range of the questions, right? And there would be chance that if you span a lot of question, then there is maximum probability that a lot of question that fall in the examination, you will already have seen that kind of question in your practice, right? So the practice is a key after you have clarity on the concept, right? All right, so you can just go and watch my all lectures. All lectures are completely free of cost on the YouTube, and you will have a separate playlist for that, right? And if you want to have a practice problem of this kind that we have already gone through and more than that, then you just need to enroll for this course of the probability and statistics on mindspaneducation.com, and those are at a very minimal cost, right? So you so there you will find at least 200 plus question, right? And more we are adding from the previous year, and a lot of questions are from the standard book, and those questions are very good. So once you will get enrolled and go through, then you will have the realization that what kind of questions are there, and all those questions are the chapter wise, right? You will find most of the questions chapter wise, right? And one more thing is that each and every question will have the detailed explanation, step by step explanation, right? शायद ही किसी क्वेश्चन का नहीं हो एक्सप्लेनेशन, अदरवाइज मुझे लगता है कि 100% होगा जिसका कि सबका एक्सप्लेनेशन होगा, right? So you just need to go and visit, and if you would like to solve more and more problem, you can just enroll to the probability and statistics. And as well as we have already covered the linear algebra last year, and now we have put almost more than 250 questions on our platform, so you can enroll for the linear algebra. And we have already covered one more subject of the mathematics, that is the calculus and optimization. So same way you will also find the practice problems for that also, and all the videos of the mathematics part of the probability of the linear algebra or the calculus and optimization, all the lectures are available completely free of cost on the YouTube platform, right? Okay, that is all. We have managed to solve each and every question of GATE DA 2025 paper, and we have looked each and every concept that needs to be talked about throughout these question. Thank you so much.